Alright, in class we talked about type 1 and type 2 errors. Type 1 is H sub O is true, but we reject. And alpha is the chance of making a type 1 error. Type 2 error is that the alternate is true, but we fail to reject. And we call that error sometimes beta. And power is the power of something is correctly picking the null hypothesis. What is the percentage? And it is 1 by 1 minus b. So that is the type 1 and type 2 and the power errors, and we're going to see how to increase power in a few different examples. So in this first example, we got mu equals 100, and according to this, the standard deviation is going to be 10 divided by the square root of 30. With alpha being 0.05 and the mu is being less than, I need to find out where my rejection is. So what I'm going to do is I'm going to do inverse norm 0.05, because that's when the 5% is going to come in, with a mean of 100 and a standard deviation of 10 divided by the square root of 30. And that gives me 96.996, so I'm going to round that to be x bar equals 97. Now, in this situation, I will reject the stuff that's over there, and in this example, I'm going to say that in reality, we are at 98. So I'm going to draw my second normal curve over here, and mu equals 98, and the standard deviation equals 10 over the square root of 30. And so here is 97. So if this is 97, I am only going to reject this part over here. So x bar equals 97 is right here, and over here, this shaded area is my power. This part over here, which is where I would fail to reject, would be my type 2 error. You notice that either you have the power or you have a type 2 error. So I'm going to do a norm CDF, and it's going to go from a negative big number to 97 with a mean of 98 and a standard deviation of 10 over the square root of 30, and we will find our power for this first one. So we got an answer of 0.291, so my power is at about 29.1%, actually 29.2% if I round correctly. And so we're going to show us ways to increase the power. So let's say that instead of this being 0.05, we are going to do it with 0.10. So I've changed this. Well, this is still mu equals 100. The standard deviation is still sigma equals 10 over the square root of 30. But this time, I have a bigger chunk down here to make this 0.1 alpha. So when I go back through my inverse norm and I change this to be 0.1, comma 100, comma 10 over the square root of 30, it tells me that this is going to happen at 97.66. And so this is the area in which I would reject now. And so if I want to reject correctly, I need to use that in my green normal curve. 100 mu equals 10 over the square root of 30. And here is x bar equals 97.66. And in this picture, that shouldn't be 100, that should be 98 because we're doing the true one. So 97.66 is really close to that. This is x bar and this is mu of x bar. And so when I do my normal CDF, it's going to be from negative big number to 97.66, mean of 98, standard deviation of 10 over the square root of 30, and that's going to give me my power this time, which means my power is now 42.6%. And so it used to be 29%, now it's 42.6%. So one way to increase power is to increase alpha. The next thing we're going to do is we're going to increase n. Let's say that I double the number of people that I'm going to test. So 100 sigma changes to be 10 over the square root of 60. And we're going back to our original problem, so we're still going to have an alpha equaling 0.05. So what is the value in which I'm going to reject? So we do our inverse norm, except for we change the standard deviation. And once again, remember we're using 0.05 again, which means that this is 97.8. And the second one, this is 98, 10 over the square root of 60, 97.8. Actually, it should be 97.9, so we change that to 97.9. X bar equals 97.9 right here. And so we're shading all of this stuff over here. So we're doing our normal CDF up to there. Here's my mean and standard deviation. And so what is the power going to be this time? Here we have a power of 46.9%. So when we increase sample size, we increase our power. The last way I'm going to show to increase power is I'm going to change this 98 to be even further away. So let's say that this is 96. Going back to the first graph I had, this doesn't change at all if I'm just going to change the new mean. So the important X bar here was 97. So coming back over here, we got 96 in the middle. We have an X bar of 97 over here. Sigma equals 30 over the square root of, sorry, not 30, 10 over the square root of 30. And since this is 97, we're shading all of this. So I'm sure that my power for this one is going to be even higher than 50%. So we're going to do our normal CDF from the low number to 97 with a mean of 96 and 10 over the square root of 30. And so the power here was 0.708, which is 70.8%. So what I call this is moving the mean farther away. And actually sometimes you're able to do that, and this is a way to kind of test, if you did have something, how far you can move it and what the power would be. So to sum up what we did here, to increase power, we can, 1, increase alpha. 2, we can increase sample size. 3, we can increase the difference between test mean or proportion and actual mean. And number 4, which we didn't talk about because it doesn't come up very often, is we can decrease the population standard deviation. That one comes up the least because it's hard to change the standard deviation of an entire population unless we're talking about machinery or something that we can control the entire population. So that's my video on